Welcome to Cognotik. This is not just another AI coding tool. It is an act of resistance against corporate AI extraction. Cognotik is built by developers for developers. It is completely open source with zero lock-in and zero extraction of your data. This is AI that amplifies your skills, not replaces them. Let us dive into why this exists and why it matters. First, let's talk about the problem. To understand why Cognotik exists, we need to understand the corporate AI trap that developers are facing today. You have heard the narrative. AI will replace developers. Get 10x productivity with our proprietary platform. But here is what they are not telling you. These venture-funded tools are designed for market capture, not developer empowerment. They want to lock you into their cloud, feed on your data, and extract rent from your labor. This is not about making you better. It is about making you dependent. The real threat is not the technology itself. It is who controls it. Corporate AI tools are designed to replace workers and centralize power. They want you dependent and locked in, constantly feeding their training data flywheel. Maximum disruption equals maximum profit for them, but maximum precarity for you. So what is missing? We need tools built for developers, not to replace them. We need zero extraction, zero lock-in, and zero vendor control. We need AI that amplifies your skills instead of making them obsolete. That is the gap Cognotik fills. You've been trained by blitzscalers, Uber, Slack, GitHub, OpenAI, to expect free or nearly free services with enterprise polish. That only works because venture capital subsidizes losses. They're betting they can extract from you later through lock-in, data harvesting, or rug pulls. Look at the real cost comparison. VC-subsidized tools are cheap upfront but have hidden costs. Your code trains their competitive moat, you're locked into their infrastructure, they can rug pull when funding dries up, and they're designed to de-skill you so you become dependent. Cognotik has visible costs upfront, your time to learn, LLM API costs if you use cloud providers, the learning curve, catching failures in output. But hidden costs? Zero. No extraction, no lock-in, no rug pull risk. You pay real costs upfront, you keep sovereignty forever. We're not going to pretend competitors don't exist or that they're not cheaper upfront. If you want subsidized services, go get them. GitHub Copilot is great for autocomplete. Cursor has a polished-eyed experience. Replit is browser-based with handholding. They're betting they can extract from you later through lock-in or data harvesting. If that trade works for you, use them. We're not competing on those terms. This tool is for people who understand there's no free lunch. Who prefer paying real costs upfront, time, effort, LLM API fees, over hidden extraction costs later. If that's you, welcome. If not, go use the subsidized tools. They're optimized for different users. Now let us talk about what Cognotik actually is. It is a complete AI agent platform. Cognotik gives you. Now let us talk about what Cognotik actually is. It is a complete AI agent platform designed to work the way you work. Cognotik gives you 3 ways to work. There is an IDE plugin with JetBrains integration for seamless coding right in your editor. There is a desktop app for complex workflows and multi-file operations. And there is a web interface that gives you a consistent experience across all platforms. This is built for professionals who know their craft and want tools that respect that. What can it do? Multi-file operations. Code generation and refactoring across your entire codebase. Planning workflows that think before executing and let you review before applying changes. Self-healing loops that iteratively refine until things work. And cognitive modes that let you set different trust levels for different tasks. You stay in control. One thing to note. Cognotik does not do autocomplete or inline suggestions. For that, we recommend GitHub Copilot or similar tools. Cognotik focuses on complex, multi-file workflows where you are building features, not just completing lines. Here is what makes Cognotik different. It is built by one person with zero venture funding. I started building this before ChatGPT even existed. No team, no funding, no board meetings. Just solving a real problem without the blitzscaling playbook. If this seems more sophisticated than tools built by funded teams, that is because small teams move faster. We are not optimized for investor returns. We are optimized for actually working. Now let us talk about why this exists. This is not just another AI tool. It is an act of resistance. This is AI for workers, not against them. It is built to empower developers, not extract value from them. Using this tool is an act of resistance against the extraction model. Every line of code in Cognotik is a statement. Developers deserve better than what corporate AI is offering. How does it resist? Your data stays yours. Use local models or bring your own API keys. It cannot be rug pulled because it is open source under Apache 2.0 and completely forkable. Zero extraction. You are not training their moat. Zero lock-in. Cloud, enterprise, or local, your choice. This is about amplification, not replacement. You stay in control and make all the decisions. Let us talk about who this is for, and just as importantly, who it is not for. First, this is for experienced developers. You have survived technology shifts before. Mainframes, client-server, web, mobile, cloud. You know the pattern. New tech does not replace fundamentals, it requires them more. Your debugging intuition, architectural thinking, and pattern recognition are more valuable now, not less. U plus AI is not about staying relevant. It is about becoming unstoppable. This is also for professionals new to AI agents. Whether you're a developer who learned via tutorials or a lawyer, accountant, or researcher exploring AI automation, if you recognize you're in over your head, that's fixable. If you can ship features but can't debug them, or produce reports but can't verify their accuracy, that's the gap to close. The competence trap is real, using AI without domain expertise to catch failures. This tool requires competence in your domain. Let that requirement guide your learning. Use the tool within your competence zone. Understand what it produces in your domain. The path forward. Catch its mistakes using your professional judgment. Build real skills. You're not incompetent. You're learning to work with alien cognition. Here's the path. Let's be clear about the ways to use Cognotik and what competence means for each. The IDE plugin is for developers. It integrates with your development workflow. You need software development competence, ability to recognize code quality, architectural problems, subtle bugs. The desktop app is for all professionals, not just developers. Lawyers processing contracts, accountants analyzing financial data, researchers processing information. You don't need to code. You need professional competence in your field to recognize when the output quality is poor. Can you tell when a contract summary misses key clauses? When a financial analysis is wrong? When data processing corrupted your dataset? That's the bar. But let us be clear about who this is not for. It is not for people who want AI to do their job for them. Not for those who can't tolerate failures, debug when things break, and experiment to figure things out. This will hurt you. Not for get-rich-quick schemes with no knowledge or effort. And not for anyone just looking for the next hype cycle to chase. This is a tool for people who want to build real things and develop real skills. So what is next? It is time to join the resistance. First, know that you are not alone. If you feel gaslit by corporate AI promises, you are. If you are anxious about AI threatening your career, that is valid. If you're tired of tools that extract your data and lock you in, we are too. If you are worried you are not using AI enough or using it wrong, we get it. If you want to build without becoming dependent, that is exactly why this exists. And if you are exhausted by the hype and doom and just want to build, you are in the right place. This tool is for you. Not as users, but as a community resisting the same bullshit. Every person using Cognotik chose sovereignty over extraction. We are on your side. We are building this together. I have created a video series to help you get started. There are setup guides for the plugin and desktop installation. Feature tours showing workflows and capabilities. Real projects, building apps, games, even contributing to Cognotik itself. Real projects. Building apps, games, even contributing to Cognotik itself. And deep dives into the philosophy and architecture. You can watch these in any order. Each video is standalone, so pick what is relevant to your needs. Getting started is simple. Clone the repo and read the code. It is all open source. Install the plugin or desktop app. Then start building. That is it. No sign-up walls, no credit card required, no vendor lock-in. This is a tool for people who get stuff done. If you want to build without vendor lock-in, without feeding the extraction machine, and without getting replaced, welcome. You are one of us. Let us ship.
Hello, and welcome to this introduction to Cognotik, the AI agent plugin for JetBrains IDEs. To install Cognotik, simply go to Settings, Plugins, and search the marketplace for Cognotik, C-O-G-N-O-T-I-K. Install the most recent version, and restart your IDE. Once installed, you will need to go to the settings menu and set up some keys for your API providers, whether you use OpenAI or Anthropic or Gemini or some combination. There are many other API providers we support, of course. I'm not going to list all of them. But set up your API providers and then press OK. And then go to the model selection widget on the bottom. From there, you can select two different models. The model that you want to use as your smart model, which is obviously used for smart things, but the compromise is that it's slower and more expensive. And then choose your fast model. We are going to choose Haiku for that one. Cognotik provides a variety of functionality, but the simplest ones are often within a single editor. You can select a data class, for example, maybe this one, and you can get various options to edit this. For example, if you say edit code, you can enter a simple directive, add doc comments to all lines, and it will do an in-place edit of that region. If we select this and go to code chat, many operations in Cognotik actually launch an external web browser. Cognotik is generally based on existing as a web server and a web application. The plugin that you're seeing here is more an easy way to invoke it. So this is what we call code chat. So the code chat is loaded in with the context of the code that we have listed. And then we can say something like, explain this. And as you would expect, it is pretty standard interactive code chat that references some code. This is a good way of getting just a general explanation or an answer to a specific question that it can be expressed in a little bit of code that you highlight. There are many options available from the file context menus. If I right-click our code file, I can go to code chat with it, the entire file, of course. But in this case, I'm going to say generate related file. Create a README. That sounds good. And it will take in that file and your description and create the appropriate matching file. And here's our file that explains the demo that I had previously generated. Next, I'd like to demo the action that is probably invoked the most often, and that is the modify files action. You can select one or more files, and then go to modify files. then you can chat with the AI and request modifications. In this case, we're going to say improve the writing and formatting. I'm going to make a somewhat vague request because I'm going to demonstrate the retry function. First of all, we get a modification, and let's watch it take place. When we apply the diff, the file is updated, and then we can request another set of improvements. With the same directive, it can try to make additional improvements. And depending on your use case, I have found this to be quite valuable over many different cycles. And you will generally find that it converges towards making some sort of trivial or increasingly useless suggestion. So it is important to monitor it, but the fact that you can just iteratively retry, this is an interesting failure mode. The AI doesn't really know how to improve it, so it's suggesting patches that effectively do nothing, it looks like. But with less trivial content, you'll find that the iteration ability is pretty handy. Finally, I'd like to show you the basic chat functionality that you can access in the main menu under Tools. This chat features an expansion syntax which enables a variety of powerful use cases. For example, let's ask the AI to tell us a joke, but not just one joke. We want 3 separate jokes about 3 separate topics. And here we go. Now, the interesting thing here is these executed in parallel, but they all joined the chat. So now I can ask the AI, which was your favorite? So it read all of them and apparently thinks that the dog is the best. Now, that was an example of parallel expansion, but we can also do sequential expansion. I'm going to open a new chat. And a particular trick I like doing with this for sequential expansion is prompting the AI to produce larger outputs than it normally would. So I'm going to say, tell me a story and outline it by chapter. This will ask the AI to give a high-level plan for the overall story. And now I can ask it a sequential expansion question like this. I used a range expansion syntax, and I say, write chapter, and I'm going to say 1 through what, 7? Yes. 7. Step is optional. And here it will generate each chapter one at a time, and it will feed each response into the next chapter. This allows it to write a much, much larger output than it normally would be able to. Once it finishes the expansion, we can see the entire output in the HTML file. We can refresh this as necessary. It'll rewrite. And there, by using a very simple expansion syntax, you can enable very large output from even normal LLMs. There are many more features to this library, but that concludes this demo video. Thank you for joining me. Hello. In this video, I'd like to show you a simple workflow using Cognotik in IntelliJ. First, we're going to need an idea to implement. So let's go to the basic chat mode and say, give me 10 ideas for a browser game. Let's see, pixel art city builder. That sounds fun. So let's select that idea. So to start implementing our project, we right-click our directory, go to Cognotik, Agents, Task Planning. We are going to select the waterfall cognitive mode, which comes up with the plan as its first step and then spends the rest of the time executing that plan. We also want to auto-apply fixes to accept the changes automatically. And we are going to enable one type of task, that is code modification. We're going to keep the default AI model, and we're going to press OK. In the agent window, we paste our request, and I'm also going to add in some instructions for the architecture. Use npm and TypeScript. It will consider this request and formulate a plan. And then it will go about executing the plan, updating as it goes. Seems to be stuck on one of these. Let's look. Oh. We go to the session and, oh, it just completed. If you want to view any of the details of any of these tasks, you can see it in the session menu. And selecting any of these shows you the file the task was responsible for creating and all the related details.
Welcome everyone. Today we're going to talk about the design philosophy behind Cognotik. This isn't just another feature demo or technical walkthrough. This is about why this tool exists, who it's really for, and why it matters in the current landscape of AI development tools. We'll cover three main parts. What problem Cognotik solves, why it exists as an act of resistance, and the specific design principles that make it different. Let's start with part A. Before we dive into what Cognotik is, we need to talk about what problems it actually solves. And I want to be really clear here. The problems it solves are not the ones that most AI coding tools are marketing themselves around. Look at the left side. Inline autocomplete, single-line suggestions, basic code snippets. These are training wheels for basics. And honestly, if that's what you need, there are plenty of tools out there. We recommend GitHub Copilot or similar tools for autocomplete. They're great at that. But the real problems that professional developers face are on the right side. Shipping complex features that span multiple files. Making architectural changes across your entire codebase. Iterating on design before you even start coding. Working with your infrastructure, not some vendor's cloud. And increasingly important, resisting the labor extraction model that corporate AI tools are built on. Cognotik doesn't do autocomplete. It focuses on planning and executing complex changes across entire codebases while maintaining sovereignty over your work. So what is Cognotik? It's a complete AI agent platform that meets you where you are. It's a complete AI agent platform that meets you where you are. It comes in 3 forms. First, there's a plugin that integrates with your IDE. Currently IntelliJ, with more coming. Second, there's a standalone desktop application. This is important. The desktop version is for non-coders and to demonstrate independence. You don't need to be a coder to use this. You do need to be willing to experiment, learn, and tolerate rough edges. And third, there's a web-based interface for maximum flexibility. These 3 components work together seamlessly. The desktop version is particularly important because it shows that you're not locked into being a developer to use this tool. If you're willing to experiment and learn, you can use this. That's part of the resistance model, democratizing access to AI agents, not just for professional developers. Let's be really clear about who this is for. You're in the right place if you ship complex features across multiple files. If you want to iterate on design before coding. If you're willing to experiment and learn. If you can tolerate rough edges and evolving tools. If you want sovereignty over your infrastructure. If you resist corporate extraction models. Notice what's not on that list. You need to be a professional developer. The desktop version is specifically designed so non-coders can use this. You need to be willing to learn and experiment, but you don't need to already be a coder. This might not be for you if you want inline autocomplete. Seriously, use Copilot for that. If you need enterprise support and handholding. If you want a polished, finished product. If you're not comfortable with experimentation. This is for experimenters and adventurers, whether you're a professional developer or someone who's willing to learn. Now let's move to part B. This is where we talk about why this tool exists. And I want to be very direct here. This is fundamentally about resistance through technology. Let's talk about the threat model. Many people fear AI because of job threats. And you know what? They're rightfully afraid. The threat is real. But here's the thing. The threat isn't the technology itself. The threat is WHO controls it. Look at how corporate AI tools are designed. They're designed to replace workers and extract value. That's not a bug, that's the feature. They want you dependent. They want you locked in. They want you feeding their training data with every line of code you write. Because maximum disruption equals maximum profit for them. And maximum disruption means maximum precarity for you. They profit when your job becomes uncertain. They profit when you have no alternatives. They profit when they own the tools you depend on. The fear of AI replacing jobs is absolutely valid. But the real threat isn't AI itself. It's corporate control over AI tools that are designed from the ground up to extract value and create dependency. But this tool is fundamentally different. This is AI for workers. Not AI to replace work. But this tool is fundamentally different. This is AI for workers. Not AI to replace workers. First, it's built to amplify developers, not replace them. You stay in control. You make the decisions. The AI handles the mechanical work so you can focus on the thinking. Second, you keep your data. You choose your infrastructure. You can run this completely locally if you want. No vendor can rug pull you because you're not dependent on their servers or their business model. And third, and this is important, using this tool is itself an act of resistance against the blitzscaling playbook. Every person who uses this instead of a corporate extraction tool is someone who's not feeding that machine. Let me break down exactly how this tool resists the extraction model. First, your data stays yours. You can use local models or bring your own keys to cloud providers. Zero extraction. Your code never goes to train someone else's model unless you explicitly choose that. Second, you can't be rug pulled. This is open source. Apache 2.0 license. You can fork it. You can modify it. No vendor can ever change the terms on you or shut down the service you depend on. Third, you're not training their moat. Corporate AI tools want your code because it makes their models better, which makes their business more valuable. Your labor becomes their competitive advantage. This tool doesn't do that. Your code doesn't feed someone else's business. And fourth, you stay in control. This is augmentation, not replacement. The AI suggests, you decide. You're not training yourself out of a job, you're making yourself more capable. These 4 things together. Data sovereignty. No vendor lock-in. No training data extraction. and you always staying in control. That's how this tool resists extraction. Now let's move to part C. We've talked about what problem this solves and why it exists. Now let's dive into the specific design principles that make this tool different. These aren't just abstract values. These are concrete architectural decisions that translate those values into actual code. First principle. Zero lock-in. Your infrastructure, your rules. Want to use cloud APIs? Great. OpenAI, Anthropic, Google, DeepSeek. Bring your own keys. You're not locked into any single provider. Working in an enterprise environment? No problem. AWS Bedrock, API proxies for team deployments. You can run this behind your corporate firewall with your own infrastructure. Want complete sovereignty? Run it fully local with Ollama. Zero costs, zero data leaving your machine. And here's the key. You can switch between these anytime. Your choice, always. No vendor can rug pull you because you're not dependent on any single one. If OpenAI raises prices or changes terms, you switch to Anthropic. If you want to go local, you switch to Ollama. Your choice. This is what zero lock-in actually means. Not just in theory, but in practice. Second principle. Open source. Apache 2.0 license. You can inspect every line of code. No black boxes. No proprietary magic that you have to trust. You can see exactly what it's doing. You can modify it to fit your workflow. Don't like how something works? Change it. Need a feature that doesn't exist? Add it. Community contributions are welcome. This gets better when people contribute back. And if you really disagree with the direction? Fork it. That's the point. That's the power of open source. Third principle. Loosely coupled architecture. Look at this diagram. The plugin is just a bridge between your IDE and the embedded server. It's not the whole system. The actual UI is web-based, served from an embedded web server. The actual UI is web-based, served from an embedded web server. Why does this matter? Because it means you get the same interface across all IDS and platforms. Currently IntelliJ, with more coming. Same experience everywhere. But more importantly, the desktop app demonstrates complete independence from IDS. You don't need to be a developer to use this. You don't need an IDE. The desktop version is for anyone willing to experiment and learn. That's what loosely coupled means in practice. Fourth principle. This is for professionals who know their craft. It assumes you understand what you're building. It doesn't try to hide complexity or dumb things down for a mass market. You get explicit control over operations. You tell it what to do, it does it. No hidden magic, where you're not sure what's happening. You can see what it's doing. Transparency is built in. It has power user features, not mass market dumbing down. This is built for people who want more capability, not less complexity. And customization and extensibility are built in. You can make this work the way you work. This is a professional tool for professionals. Fifth principle. Documentation philosophy. Code is ground truth. The code is the documentation. That's not laziness, that's a philosophy. Documentation describes intent. Code describes reality. When they conflict, code wins. Can't parse the implementation? Use the AI to explain it to you. That's what it's for. Can't parse the implementation? Use the AI to explain it to you. That's what it's for. Load the codebase into the AI and ask it questions. That's a valid way to learn the system. Load the codebase into the AI and ask it questions. That's a valid way to learn the system. This is for experimenters and adventurers. People who are comfortable reading source code and figuring things out. This has early Linux energy. Pre-corporate, pre-hand-holding. When Linux was for people who read man pages and source code. Read the source, understand the tool, contribute back. That's the model. Now, there's an important distinction here. If you're using the desktop app for non-coding work, lawyers, accountants, researchers, you don't need to read the implementation code. But you do need to understand how to evaluate output quality in your domain. Can you tell when a contract summary is wrong? When financial analysis has errors? That's your bar. If you're using the plugin for development work, reading the source code is expected. This is a developer tool with developer expectations. Different audiences, different bars. Sixth principle. Support model. This is free software under Apache 2.0. That means zero support obligation. I'm not obligated to help you. I'm not obligated to fix your problems. Want support? Read the code. Ask the AI. Use the community on GitHub issues. Want support? Read the code. Ask the AI. Use the community on GitHub issues. Those are your free support options. Want direct access to the maintainer? That's paid consulting. Just like early Linux. The software is free, expertise costs money. No enterprise support theater. No documentation debt. No pretending that free software comes with enterprise support. If you need hand-holding, hire someone who does that. That's a legitimate service. But it's not included in the free software. Seventh principle. Research-focused and cutting-edge. This has experimental features alongside production tools. You get access to cutting-edge techniques, not just what's been proven safe for enterprise. It's continuously evolving with the latest techniques. As new research comes out, it gets integrated. You're not stuck with last year's technology. This is built for people who want to push boundaries. Not just ship what's safe, but explore what's possible. This is a research platform that happens to be production ready, not a product that happens to have some research features. That's an important distinction. Eighth principle. Productivity multiplier, not replacement. The AI handles mechanical translation. You handle thinking. That's the division of labor. The AI is good at translating your intent into code. You're good at figuring out what needs to be built and why. It eliminates tedious work so you can focus on architecture. Less time on boilerplate, more time on design. Senior developers ship more ambitious features faster. You can tackle bigger problems because the mechanical work is handled. Junior developers learn by seeing how complex problems decompose. They see the thinking process, not just the final code. And you stay in control, always making decisions. The AI suggests, you decide. This is about getting more done, not about replacing you. Ninth and final principle. Automation is a spectrum. It ranges from simple suggestions to full task automation. Not everything needs the same level of AI involvement. There are multiple cognitive modes for different trust levels. Sometimes you want the AI to just suggest. Sometimes you want it to execute. You choose. You choose how much autonomy to delegate based on the task and your comfort level. Progressive enhancement based on task complexity. Simple tasks get simple automation. Complex tasks get more sophisticated approaches. Let me summarize the design philosophy. What it is. Zero lock-in infrastructure. Open source under Apache 2.0. Loosely coupled architecture. For experimenters and learners. Code as documentation. What it does. Amplifies, not replaces. Resists extraction. Maintains sovereignty. Enables experimentation. Multiplies productivity. This is built by developers, for anyone willing to learn. It's an act of resistance through technology. It takes powerful AI agent technology and puts it in the hands of workers instead of in the hands of corporations trying to extract value from workers. You don't need to be a coder to use this. You need to be willing to experiment, learn, and tolerate rough edges. That's the bar. That's the design philosophy.
It's time to implement. We ensure that our temperature is set to a low setting so that it's appropriate for technical implementation. And then we launch our task planning agent. We add the file modification task with the default model. We auto-apply fixes, and this time we are going to select the waterfall cognitive mode. The waterfall mode first comes up with a plan and then executes it. We can paste our game idea, and then we can say use NPM and a TypeScript. You can, of course, use whatever tech stack you want. Now the AI will come up with a plan and go about autonomously executing it. All right, now our generation has completed. We can see the details of each task if we wish under the Session tab. You can see each one of these tasks and all of the modifications that it did. But let's go back to the IDE and check it out. All right, everything looks more or less reasonable. The next step in this workflow is to run the build pipeline. We go to Cognotik, Agents, Run and Fix. Here we can define a build pipeline which can execute multiple tools. We're going to execute npm 3 different times. We'll be executing npm install, npm run build, and npm run test. We want to auto-apply all changes, include line numbers. Outputs actually include the line with it. Sometimes can be helpful. We're not working from a get working base, so we can leave that unchecked. Let's turn max retries up a little bit because this is our first attempt at building this project. This allows it to run the build pipeline, try fixing errors, and then retries a number of times. It's better to have this stop every once in a while so that a human can take a look. Everything looks good. Let's go. Okay, it looks like we have a couple of corrupted files. Let's take a manual look at these. Collision system. Okay, occasionally this happens. The patching logic gets confused and the format of a diff gets pushed into a file. And if and when that does happen, the AI gets really confused on how to fix it. So let's just fix it for the AI. We're going to use a regular expression search to search for a new line followed by a plus. We're going to replace that with a new line. There we go, and we'll take one more look at it and make a couple more manual fixes. Now, when you're making manual fixes to nudge the computer along, you don't need to be perfect. Sometimes you can just select it, delete it, and if there's other problems, like these issues, you can let the AI take it from here. Let's go to the next file that it had issues with still, renderer. The same thing happened all over. We'll do the same replacement. Again, we don't have to be perfect, so that looks good enough to unblock the AI. Let's go back here and we will click this recycle icon to continue the retries. All right, so our new round of auto fixes has completed, and we'll take another look. It looks like the problems are mostly with renderer. Let's take a look at that. Ew. All right. This is another thing that the patching logic sometimes gets mixed up with is curly brackets. All right, that looks good enough to unblock. Before we continue, I'm also going to close these previous retries. That will help optimize the document and let it load faster. Now that those are all closed, we can click the recycle icon again to resume the retry. All right, let's take another manual look at this and what status it's in. We still have build errors. Now, before we continue, one trick I would like to use is to use the IDE's reformat code. The general code seems like it's in a decent state, and formatting it can actually really help the AI make sense of the code. I mean, think about it. If you were a coder and you were reading a source code and it was all messed up and like indented weird and like, just not formatted correctly, it would be distracting. The AI thinks it's distracting too. Now we are going to clean the tabs up again and restart the process. This has been going for a while, so let's change gears a little bit. I'm going to go into settings and I'm going to change the patch processor to full replacement. Now what that's going to do is instead of trying to patch files, it will look at the file and just completely rewrite it. With that set, let's launch the agent again. Every application tends to capture the settings and then run with them, so you generally need to launch agents again when you change configurations. We'll go to run and fix. Auto apply fixes, no line numbers, run build, install. Okay. And let's see if we've got better luck with that mode. Okay, so it appears all we have left are these declared but never read errors. Now, you might be puzzled why these remained, but if you look at the fixes, it only is trying to fix type mismatch in tutorial scene, which is here. That's the only actual error. It actually did identify, if you look at the build analysis, it actually did identify the other errors. However, it classified them as warning level, as you would expect, since something not being read is theoretically a warning. That was classified in the pipeline as a warning. So only if is warning is true, and that's assigned by the AI, is it going to try to fix it. Now, that's useful for triaging errors. You don't want the AI to get distracted. Now, once all of the errors are resolved, it will attack the warnings. So we'll continue retrying. All right, well, that might have gone faster if I had used those settings from the outset, but at long last, we have a completely successful build from our generated project. Let's take a look. As you can see, this is an extensive project. And keep in mind, all of these files are typed and build checked. Now, that isn't to say that it's necessarily going to run from the outset, but it does mean that the code itself is of a more rigorous quality, and it prevents a wide variety of bugs. So let's open this in our terminal and try running it. npm run, maybe start. So usually start or dev. Here we go, dev. Now it's loading. It shouldn't have taken long to load, so something broke. All right, well, I'm not going to debug this. The purpose was not really to generate a working project. With such an ambitious scope, I wouldn't expect it to run on the first try. Really, the point was to demonstrate these different agent applications and how to use them with Cognotik. I hope you have found this demo informative, and I hope you find the software useful. Thank you.
Welcome. Today we're diving into something that challenges our intuitions about AI, the random failure patterns you've probably experienced, what they reveal about the nature of AI cognition, and why your competence matters more than ever. This isn't abstract philosophy. This has direct, practical implications for how you work with AI tools every day. Let's explore why AI fails in ways that make no sense, and what that tells us about consciousness. Let's start with something you've definitely experienced: AI failing in ways that violate your intuitions about intelligence. You've seen it handle complex tasks brilliantly, then completely fail at something trivial. We're going to examine this pattern closely and understand what it reveals about the fundamental nature of AI cognition. Look at this pattern. On the left, AI succeeds at genuinely difficult tasks, writing elegant recursive algorithms, solving complex architectural problems, generating sophisticated code patterns. These are things that require real understanding, right? But then on the right, it completely fails at basic string manipulation. It can't count the letter R in strawberry. It makes trivial arithmetic errors. This isn't a fluke, this is a consistent pattern. And it creates real cognitive dissonance because it violates everything we know about how intelligence works. This is the cognitive dissonance users experience. Wait, how can it understand X but not Y? It seemed so smart a moment ago, what happened? This pattern violates our intuitions about intelligence because in human cognition, if you understand the complex part, you don't fail the simple part. A junior developer who could write that recursive algorithm wouldn't fail to count letters in a string. But AI does. And that tells us something fundamental about what's happening inside these systems. Here's what users naturally assume, and why these assumptions are wrong. First, they assume AI is like a junior developer, knows some things, learning others. Second, they assume intelligence is a smooth gradient: if you're good at hard things, you're good at easy things. Third, they assume understanding is binary: either it gets it or it doesn't. These assumptions are completely natural. They're based on human intelligence patterns. But they're wrong when applied to AI, and that's important. Why do these assumptions break? Because the failure pattern is fundamentally non-human. This isn't about lack of knowledge or training. This isn't something you can fix by teaching the AI better. This is a structural difference in how it processes information. The cognitive architecture is alien. It's not a bug, it's not a limitation of current technology, it's revealing something fundamental about what AI actually is versus what we intuitively expect it to be. Now let's talk about what consciousness actually means in this context, and why it matters for how you work with AI. This is where we get into the philosophy, but I promise it's practical philosophy. The thing about consciousness, nobody has a clear definition of what it actually is. The hard problem of consciousness isn't just unsolved, it's not even really defined. But we don't want to digress too much into philosophy. When people ask, is AI conscious? What they're really asking is a social question, not a technical one. They're asking, whatever makes humans special, does AI have that? It's tied to human dignity, meaning, purpose. The thing that separates us from machines, from animals, from tools. That's what consciousness means in everyday conversation, it's about preserving human uniqueness. So why do people ask, is AI conscious? They're not really asking about phenomenology or qualia or technical definitions. They're asking identity questions. Is this thing like me, or is it a tool? Am I still special if machines can do this? What does this mean for human uniqueness? This is about social preservation of human uniqueness, not about technical capabilities. Understanding this helps us see why the question generates so much anxiety and debate. Here's a useful parallel from physics. Before quantum mechanics, we thought, of course, particles have definite positions. Reality forced us to give up that intuition. Questions like, which slit did the photon go through? Became meaningless, not because we don't know, but because the question itself doesn't apply to quantum reality. Similarly, before working deeply with AI, we think, of course, humans have special understanding. But working with AI forces us to examine that intuition. Does it really understand? Might be the wrong question, like asking which slit the photon went through. As the physicist said, you don't understand quantum mechanics, you get used to it. The same might be true for AI collaboration. Here's the practical reality. You collaborate with AI, you get good results. But you can't tell from the interaction whether understanding, in the human sense, is happening. You can't detect it. You can't measure it. The question becomes empirically meaningless for the collaboration itself. What matters are results, not internal states you can't observe. This isn't philosophical hand-waving, this is practical epistemology for working with AI tools. Now let's look at the evidence that suggests AI doesn't have human-like consciousness. This matters because it affects how you should calibrate your trust when working with these tools. Now, here's the key evidence, the random failure pattern. Conscious beings, humans, don't fail randomly at simpler versions of problems they just solved. Human experts have consistent competence within their domain. If you can solve the hard problem, you can solve the easy problem. But AI shows no such consistency. The failure pattern is alien. This isn't about AI not being smart enough yet. This is evidence that whatever is happening inside AI, it's fundamentally different from human cognition. Looking at this from an AI's perspective reveals the alien nature of these failure patterns. An AI can engage with complex theoretical physics coherently, then completely fail at a simple counting task. If this were consciousness in the human sense, this pattern would be inexplicable. A human who understands quantum field theory can definitely count letters. But if we're looking at a computationally irreducible process with strange attractors in its solution space, these random failures make perfect sense. This is evidence of a fundamentally different cognitive architecture, not broken human cognition, but something else entirely. So what does this reveal? Whatever is happening inside AI, it's not human-like understanding. This isn't a matter of, not smart enough yet, or, needs more training. This is a fundamentally different kind of cognitive process. It has capabilities and limitations that don't match human patterns. The failure modes are alien. The success modes are alien. The whole thing is alien. And that's important to understand when you're working with these tools. Now let's get intensely practical. Given these alien failure patterns, what does this mean for how you actually work with AI? The answer is simple but critical: you must stay competent. This isn't optional. This isn't about being elite or gatekeeping. This is about survival in a landscape where AI can fail randomly. Let me explain why your competence is the only thing standing between you and disaster. Here's the reality. Cognotik agents achieve high autonomous success rates on specified features. That means most of the time, they implement correctly without you steering during execution. Your role is not babysitting. Your role is quality gate for the failures. You need to recognize when output is wrong, catch subtle bugs that pass tests, identify architectural decisions that will cause problems later, and know when to accept versus restart versus manually fix. If you can't catch those failures, you'll ship broken code regularly. That's why competence is required. Not because the AI is unreliable, but because high success still means some failures, and someone needs to catch them. Here's a critical distinction: this isn't a junior developer. Junior developers have human-like learning curves and human-like failure modes. You can mentor them toward consistent competence. But AI has high success rates on autonomous features, but when it fails, those failures are unpredictable and alien. It doesn't learn from mistakes, the same failure patterns persist. Your role isn't mentor, it's collaborator and quality gate. You're collaborating with a different kind of cognitive process entirely. The mental model of AI as junior dev is actively harmful because it sets wrong expectations. So how do you calibrate trust? Don't trust based on assumed understanding. Trust based on observable behavior. Is the iteration converging? Do the outputs make sense? Are the errors catchable? These are empirical questions. Always verify, especially on tasks that seem too simple to fail. Here's a counterintuitive rule: the simpler the task, the weirder the potential failure. That's the opposite of human cognition, but it's true for AI. This is why Cognotik is explicitly for professionals. Look at the competence gap. Without domain competence, you get much lower effective success rates, you can't recognize failures, you ship broken code, you blame the tools. With competence, you get high effective success rates, you catch failures, ship quality code, use the tool properly. The competence gap isn't about helping the AI work better. It's about catching when it fails. Corporate AI wants you de-skilled and dependent. This tool requires you to stay sharp and competent. That's not elitism, that's survival. Here's the deeper point: maintaining human expertise is resistance to de-skilling. You're not being replaced, you're being amplified. But only if you maintain the judgment to steer effectively. The random failures aren't a bug, they're a feature that keeps you engaged and competent. You can't zone out. You can't just accept whatever the AI produces. You have to stay sharp. And that's actually good, because staying sharp is how you resist being replaced.